Welcome to the second demo of the SAR Table app for iOS-based devices. In this example, we're going to start with a collection of chemical structures which have already been drawn out in full, and we're going to use scaffold matching features to decompose them into core scaffolds and substituents. These are the structures that we're going to use, and as you can see, they're suitable for representation in the form of scaffolds and substituents. We have these structures available in the form of an SD file, so the first thing to do is to import them into the SAR Table app. The new table features a column called Molecule, which contains the whole structure for each compound. We're going to work back from these structures in order to gain these scaffold substituent components. For the first row, we need to supply the core substructure for the scaffold. The easiest way to do this is to copy over the molecule and then trim pieces off. Notice that we did not bother to draw any R groups because this is going to be done for us. We select the Scaffold Match button and confirm what we want to match. The request will be sent to a web service which analyzes all of the possibilities and comes back with a bunch of suggestions. We like the first one, so we select it and accept it. 3 new columns are created, R1, R2 and R3, and notice also that the scaffold has been updated to include these decorations. For the second row, we reuse the previous scaffold. And then we submit it to the scaffold matching service. Because we've already specified the R group labels, we only get one result, which is what we want. We repeat this process for the third row. And the fourth row. And so on for the next few rows. Now compound ID 20 has a different scaffold. We can build this by copying and trimming just like we did with the first row. When we match the scaffold, you can see that the R2 and R3 labels are not used because they're not necessary. The same process applies to the next compound, except that we have to clip off 2 substituent groups. Because we did not specify the R group labels, there are 2 possible assignments, but note the order in which they're returned. The first result is given priority because the substituent fragments match existing assignments. The next few scaffolds are similarly unique, so we will treat them in the same way. Note that the auto-assigned label, R2, is actually not what we want. It should actually be R3, which we can fix easily enough. The next two compounds are based on the same scaffold. Notice that the first of these assignments only comes up with one R group substituent. When we duplicate the scaffold for the second row, the assignment provides us with the second R group label. For the final compound, the labels we want to use are R1 and R3, so it's easier to simply provide these when we trim down to create the scaffold. This concludes the second SAR Table Demo. For more information, see the Molecular Materials Informatics website.